Section 1.1 is exponents, order of operations, and inequalities. So we'll start with exponents. We'll start with the exponential notation. So exponential notation is going to be this notation that's written right over here. It's b to the n. So this b is the base, so b for base. The superscript right here is the exponent or the power. So what this means is that we're multiplying b by itself n number of times. So b to the nth power equals b times b times b n times. That means there are n factors of b. Okay, and just like I read it, b to the nth power or b to the power of n. And something to keep in mind is that b to the 0 power is equal to 1. And b to the first power is equal to b. So let's see some examples here. For the first one, let's say we have 7 to the 0. So anything to the 0 power other than 0, but we won't worry about that. Anything to the 0 power is equal to 1. Okay, and then next one, let's say we have 8 to the first power. So 8 to the first power would just be 8. Next one, say we have 5 to the second power. So this is equal to 5 times 5, which is 25. So 5 multiplied together twice. Whenever we have an exponent of 2, we can just say that that is squared. So that's 5 squared is 25. For another one, say we have 4 to the third. So that's 4 multiplied together 3 times, which is going to give us 64. So anytime we have 3 as an exponent, we can read that as cubed. So we would say 4 cubed equals 64. So 2 more here. So let's do 3 to the fourth. 3 to the fourth, that's 3 times 3 times 3 times 3, which is 81. And for one more, just to kind of get us thinking a little bit here, let's do negative 2 to the fifth. So negative 2 to the fifth, so negative 2 is the base. So we're going to be multiplying negative 2 together 5 times. And what we get is there's going to be 5 negatives being multiplied. So the first 2 are going to multiply negative by negative. It's going to become positive. The next pair are going to be negative times negative. It's going to be positive. We're going to have one leftover negative that does not pair up, making the whole thing negative. And 2 to the 5th power is 32. So negative 32. Okay, so for the next thing is going to be order of operations. So when we're evaluating an expression, the way that we evaluate it matters. The order in which we do it matters. So the first thing we have to do is we have to simplify what's inside parentheses first. The second thing is we have to do exponents. Then we either have to do multiplication or division, whichever comes first from left to right. Then we have to do addition or subtraction, whichever comes first from left to right. So the way that we remember it is the first letter of each operation gives us PEMDAS. And just keep in mind that the multiplication and division are together. Multiplication is not before division. It's whichever is first from left to right. Same thing with addition and subtraction. So let's do some examples of this. So for the first one, let's simplify 4 plus 5 times 6. So there's no parentheses, no exponents. There is multiplication here. So we have to do the multiplication first. So 5 times 6 is 30. And then we just have to add 4 plus the 30 is 34. So notice if we did addition first, 4 plus 5 is 9 times 6 is 54. That would be incorrect. Next one, we have 9 times 6 plus 11. So this time we have parentheses. So we have to do the parentheses first. 6 plus 11 is 17. And then 9 times 17 is 153. Next one, 6 times 8 plus 5 times 2. So we have addition and a couple multiplications. So what I'm going to do is I'm going to do both of those multiplications first because they're both separated by addition. So 6 times 8 is 48. 5 times 2 is 10. 48 plus 10, 58. Okay, start to get a little bit harder here. We have 7 times 3 minus 2 times 5 plus 6. So parentheses first, so I'm not going to do anything except for what's inside those parentheses. 5 plus 6 is 11. So we have 7 times 3 minus 2 times 11. So 7 times 3 is 21, minus 2 times 11 is 22. 21 minus 22 is negative 1. Next one, we have an exponent here, 9 minus 2 cubed plus 5. So we have to do the exponent first. 2 cubed is 2 times 2 times 2, which is 8. Now we have addition and subtraction. So we do whichever one comes first, left to right, which is the 9 minus 8, which is 1. So 1 plus 5, we get 6. Okay, next one, 8 squared minus 16 divided by 2 squared times 4 minus 3. So we have two sets of exponents, so we have to do both of them first. So 8 squared is 64 minus 16 divided by 2 squared is 4. Okay, now we have some subtraction and division, multiplication. So we have to do division or multiplication, whichever comes first, left to right, which happens to be the division in the middle. 16 divided by 4. 16 divided by 4 is 4. We have multiplication left, so we have to do 4 times 4, which is 16. So now we just have two subtractions, so just work left to right. 64 minus 16 is going to give us 48. And then we have 48 minus that 3, which is 45. Okay, and then for the next one, so we have 8 minus 3. So the bracket is another parenthesis. We use brackets when we have parentheses within parentheses so we don't get them confused with each other. So it's 8 minus 3 parentheses times negative 2 times 2 minus 5 minus 4 times 8 minus 6. So what I'm going to do is, based on order of operations, I'm going to go inside this big parenthesis, the big bracket, and simplify what's inside of there first. So inside of there, we actually have two other mini sets of parentheses. So I'm going to do those two. So 8 minus 3 times negative 2 times, so we have 2 minus 5, which is negative 3, minus 4, 8 times 6, which is 2. So now I'm going to do what's inside the bracket still. So we have multiplication and subtraction. So I'm going to do the multiplication. So negative 2 times negative 3 is positive 6. 4 times 2 is 8. Now just simplify 6 minus 8, which is negative 2. So this becomes a little bit easier for us. So what I'm going to do is I'm going to leave this as subtraction. I'm going to do 8 minus 3 times negative 2 is negative 6. 8 minus negative 6 is 8 plus 6, which is 14. So you didn't have to do it that way. You could have recognized negative 3 times negative 2, so that would give us plus 6, but either way you should get to the right answer. Okay, next one for this. We have a big fraction here. So I'm going to do the numerator and denominator separately. So for the numerator, we have division and we have addition, multiplication. So division comes first here. So 10 divided by 2 is 5. plus, and I might as well do multiplication while I'm at it. 3 times 4 is 12. Next, for that denominator, we have parentheses raised to an exponent. So we have to do what's inside the parentheses first. So we have to do 3 times 2 is the first one we have to do. So that's going to be 12 minus 6 squared. So the numerator, 5 plus 12 is 17. Denominator, 12 minus 6 is 6. So 6 squared. Whenever you have a number raised to an exponent, it's good to just keep the parentheses around it. If it's positive, we actually don't need those parentheses around it. If it were negative, we would need those parentheses. So 6 squared is going to be 36, so this whole thing is 17 over 36. Okay, so for one of the last things here for inequality symbols, so we've been using an equal sign a lot throughout the class. We also have these inequality symbols. So the first one, I'll go through and explain them in a second. So for the first one, we have this equal to sign with a slash to it through it. That just means is not equal to. For the next one, we have is less than. So when we're comparing quantities, that less than or greater than symbol, it opens up to the greater value. So this next one would be is greater than. And if it has a little equal line bar underneath it, then it's going to be an or equal to. So this next one is less than or equal to. And then we have the last one is greater than or equal to. So these are all examples of inequalities rather than an equal sign. And just keep in mind the little note I have down here. A is less than B is the same as B is greater than A. It's just kind of reversing the order of how you would read it. So let's do some examples to see if they're true or false. So when we're doing these, we're going to have to simplify both sides of the inequality sign separately and then compare them. So for the first one, we have 6 is not equal to 5 plus 1. So let's simplify the right-hand side. 5 plus 1 is 6. So this is saying that, let me use that in red. This is saying that 6 is not equal to 6, which is obviously false because it is equal. Next one, we have 5 plus 3 is less than 19. So 5 plus 3 is 8. 8 less than 19. Then we think, okay, is 8 less than 19? Yes, that is. So it is true. Next one, 15 less than or equal to 20 times 2. So we have to simplify that 20 times 2. 20 times 2 is 40. And 15 is less than or equal to 40. So it can either be less than or equal to. So since it is less than, it's true. If it was equal to, it would still be true. Next one, 25 greater than or equal to 30. So this one is actually already simplified for us. This one's false. 25 is not greater than or equal to 30. For E, 12 greater than or equal to 12. So this one's actually true because of the or equal to. So if this just said 12 greater than 12, it would not be true. The or equal to makes this true. So that brings us to F, 9 less than 9. 9 is not less than 9. It would have to have the or equal to in order to make it true. And for the last one here, it is a fraction. 6 over 15 greater than or equal to 2/3. We need a common denominator here. So we're going to get a common denominator and then compare the numerators. So this is going to be the same thing for the LCD here. The LCD, so remember back to finding least common denominators, is going to be 15. The multiples of 15 are 15, 30, 45, and so on. Multiples of 3 are 3, 6, 9, 12, 15. Smallest one they have in common is 15, so that's our LCD. So we need to multiply this fraction by 5 over 5. So this is going to give us 6 over 15. We didn't have to change the first one at all because it already had 15 as a denominator. So it's going to be 6 over 15 is greater than or equal to 2/3 times 5 over 5 is 10 over 15. So now we compare the numerators. 6 is not greater than or equal to 10, so this is false. So when you are comparing fractions with an inequality, it's best to get common denominators first and then compare the numerators. Okay, so this is actually it for chapter 1.1.